Alright, so now in this question, we're going to look at Bernoulli trials and look at the kind of questions they're going to ask us in the Leaving Cert about Bernoulli trials. So it could be quite a long video. I'm going to go through 8 different kind of parts, 8 different questions they can ask us. But the reason I'm going through all of it in one big video is just to show you every single type of question they can ask about Bernoulli trials, so you'll be ready no matter what they ask in the actual exam. So anyway, I'll just read the kind of start of it now. So an Irish family, they eat dinner together 10 days in a row. There is a 70% chance that they will have potatoes with their dinner each day. All of Bernoulli's requirements are met. So the last sentence there just means that each trial is independent. There's a finite number of trials, and there's only 2 outcomes: success or failure. So I'm not going to go through each one individually. Like I will when I'm answering the questions, and I'm not going to read them all out now. There'll be no point. But we'll just start at the first one, okay? So the first one is the probability that they have potatoes 8 times. So first I'll just quickly write out the formula. So there we go. It's n choose or times p to the power of or times q to the power of n minus or. So I'll write each one of these out. So n is equal to 10. They have dinner 10 times. Or we're going to say the number of times they have potatoes. That's going to be a success. In this question is equal to 8. P is going to be equal to 0.7. That's the probability of potatoes. And Q is going to be equal to 0.3. Okay, so now it's just about sticking all of these into a calculator and multiplying them all. And just the one thing I said I'd say in the next video. So n choose or. So there's a special button on the calculator for this. So on the sharps, it's above the number 5. So you have to press second function and then 5. And it looks like N, C, or. And it's actually in orange writing as well. So like on your calculator, you should write 10, C, 8. And then stick that in brackets. And then you should have everything else in brackets afterwards. On the Casios. And then on the sharp calculators, it's above the division button. And it should look the same, so it should be NCR, okay? So what you do is you're going to put all of those numbers in together. So if I were to write it out, it would look like, not N, sorry, it would be 10, choose 8, then it would be P, which is 0.7, to the power of 8, and then it would be 0.3 to the power of 2, because 10 minus 8 is going to be 2. Stick all that into your calculator, and they want it at 3 decimal places, and that'll give us the answer of 0.233. 0.233. So that's the probability that they have potatoes 8 times out of their 10 dinners. Okay, so now we'll move on to question 2. Try to keep that in the top in view there. So part 2 is that they have potatoes half of the time. So it's the same formula. In this case, n is still equal to 10, and or this time is only equal to 5. So only 5 successes. And then the P and Q, as I have here, are going to stay the same. So they're going to be the same for the whole question, because the probability of getting potatoes doesn't change. So in this case, it's going to be 10, choose 5, and it's going to be 0.7 to the power of 5, and 0.3 to the power of 5. And this is equal to 0.103. 103. Okay. So like just what the formula is doing is it's calculating just the probability of you getting potatoes 5 out of the 10 times in all the different orders. So you could be potato the first night, no potato second, potato the third, no potatoes the fourth, and so on. Or it could be any other sort of combination. So that's why it's so useful. So we showed that in the last video. The next part then they're asking is the probability they have potatoes every dinner. So again, I think I can squeeze this in the bottom. So in this case, n is equal to 10 still. In this case, or is also equals to 10. So it's a success every single time. They have potatoes every single dinner. So it's 10, choose 10, 0.7 to the power of 10. And in this case, it's 0.3 to the power of 0. So in this case, the probability is going to be 0.028, 0.028. So not that high of a probability that they will have potatoes every single day. So one thing you'll see with Bernoulli's trials is you do get quite awkward answers. Going to be lots of decimal places, and don't worry, that's just the way it is. So normally they'll ask you to give the answer in 3 significant figures or 3 decimal places or so on. So don't worry if you get a messy answer, you will get a messy answer. So I'm going to have to scroll down now. There's not going to be enough space to squeeze it in every time. We'll go to part 4. And in part 4 they said, I'll just scroll back up, the probability that they don't have potatoes on any of the days. So it's just that one there. The squiggle is probably a bit unnecessary, but anyway. So in this case, n is equal to 10, so it's still 10 dinners, and or is equal to 0. So there's no successes or they have no potatoes. So 10 choose 0, and it's going to be 0.7 to the power of 0 and 0.3 to the power of 10. And in this case, the answer is going to be quite a small number. So 0.0000590. So hopefully I've got the number of zeros right there. But that is 3 significant figures anyway. Significant figures are a little bit different to decimal places, but it's going to be quite a low number because it's not that probable to have no potatoes on any day. So hopefully all of those ones there make sense. It's just the easiest way to do it is once you have the formula in front of you, you need to find out what n is, what or is, the number of successes, what p and q are, and then it's just about sticking each one into your calculator and figuring out the number. So those first 4 ones we're just sort of getting used to Bernoulli's formula. After this, they're going to get a little bit more difficult. So I'm actually going to leave the video here for now. So just after doing 1, 2, 3, and 4, and then I'm going to split the video up into 2 separate sections. So in the next video, I'll go through part 5, 6, 7, and 8. They just take a little bit more time. I don't want the video to go on for too long. So those first 4 ones are just basic ideas of how to use Bernoulli's equation. And the next video, we're going to look at the more difficult examples. So hope you enjoyed this, and make sure you watch the next one to see the more difficult examples.